Hello everybody, welcome into another lesson. So today we are going to talk about absolute value functions and their graphs. Here we have the graph of the standard absolute value function f of x equals the absolute value of x. And as you see, you get a V-shaped graph. That alone is why the absolute value function is not considered a linear function, because for it to be linear, you have to have a straight line. But this is definitely not a straight line. This is a V-shaped curve. So that's why, even though x is to the first degree, it's not a linear function. But if we put in values of x here, if I put in 0 for x, I get a y value of 0. If I put in 1 for x, I get a y value of 1. If I put in 2, I get 2. And so from 0, 0 on upward, my graph goes that way. But what happens if I put in negative values of x? Well, if I put in negative 1 for x, the absolute value of negative 1 is positive 1. The absolute value of negative 2 is positive 2. So from 0, 0 going left, my graph goes that way. So that enables the V shape to happen with an absolute value function. So that is the general graph of the absolute value of x. And I have my line of symmetry through the y-axis, which would be at the line x equals 0. The line of symmetry, the idea is you can use that as a mirror. And if I took one half of the graph and folded it on top of the other, it would stack up evenly. That's the idea of the line of symmetry. So you're probably wondering, what the heck is this? This is the general form of the equation of an absolute value function. So you have f of x equals a times the absolute value of x minus h, all that plus k. Well, we'll get to the a in a minute, but look at the x minus h. That h is how many units the vertex is shifted, right or left. If it's minus h, it's going to shift to the right. The idea is, if you take x minus h, set it equal to 0, you would get x equals h. Now, if this were x plus h, you would still take it, set it equal to 0, x equals negative h, so it would shift left. Then that plus k, that shifts up or down. So if it's plus k, my vertex would shift upward. If it's minus k, it would shift downward. So the h indicates a horizontal shift, which would be left or right. The k indicates a vertical shift, which would be up or down. For the absolute value of x itself, I have no shift left or right, and then I have no shift up or down, so that there is no h or k. So that makes that easier. But your vertex, which in this case is 0, 0, the coordinates of your vertex would be at hk. So to find the coordinate of the vertex, set x minus h equal to 0, you would get the x coordinate of h. Put the x coordinate in, you would get the y value of k, which you can just take k as your y coordinate. You get the vertex at the point hk. Then the line of symmetry would also be through x equals h. Now, what is that a? That a is some coefficient on the outside of the absolute value function. So let's say I had the absolute value, let's say I had f of x equals 2 times the absolute value of x. Well, what's going to happen is then, since my a is greater than 1, it's going to vertically stretch it. It'll stretch it up more vertically, which will shrink it horizontally. So if my coefficient is greater than 1, it stretches it vertically, which also shrinks it horizontally. Then let's say I had f of x equals 1/2 of the absolute value of x. If that value of a is less than 1, it's a vertical shrink. It'll shrink it vertically and stretch it more horizontally. Now let's say my coefficient was negative on the outside of this. Let's say I had f of x equals negative absolute value of x. In fact, let's do that real quick. Why don't we demonstrate that real quick since it's going to be a reflection? I will quickly do that here. Let's put in, for this function, f of x equals negative of the absolute value of x. It's going to be a reflection in the x-axis. So 0, if I put in x at 0, well, the negative of 0 is still 0. If I put in 1, the absolute value of 1 is 1, but the negative sign off in front of that makes it the coordinate 1, negative 1. If I put in 2, I would end up getting 2, negative 2. So far we're going down this way. Now if I put in negative 1 for x, well, the absolute value of negative 1 is positive 1. Put a negative sign on that, you would end up getting negative 1, negative 1. If I put in negative 2, the absolute value of negative 2, well, that's going to be positive 2. Negate that, you would get negative 2, negative 2. So notice that negative sign reflects the absolute value of x here in the x-axis. So it would flip it upside down. Your vertex would still be 0, 0, but now it's flipped upside down since you have a negative sign. So we're going to do some examples here of absolute value functions. We'll graph some of them. All right, so let's see. We have here for the first one, f of x equals 3 times the absolute value of x minus 7. All right, so f of x equals 3 times the absolute value of x minus 7. First thing you want to do, identify the vertex. How do we find the vertex? Ignore that constant, that coefficient for a minute. Ignore that coefficient on the outside. Just look at the x minus 7 portion. If you set x minus 7 equal to 0, what would you get? X would equal 7. So the vertex, you'll have the x coordinate of 7, and then you see nothing added to it, which means your k is at 0. So literally my vertex would be at the point 7, 0, since I have no k value. So my vertex would be at the point 7, 0. It'll shift everything over to the right 7 units. So let's find 7, 0. There's my vertex at the point 7, 0. All right. Now what if I put in x equals 8? Let's get a couple points here. If I put in x equals 8, I would get 8 minus 7, which is 1. The absolute value of 1 is 1. Take that times that coefficient of 3, I would get 3. So I would be at the point 8, 3 for the next point. Let's even put in 9. So if I take x equals 9, right? 9 minus 7 is 2. The absolute value of 2 is 2. Take that times 3, you would get 6. So I'd be at the point 9, 6. Let's draw this half of the absolute value graph. All right, let's put in 6 for x. So in general, when you're graphing these, you want to do about 2 points to the right of the the vertex itself, 2 points to the right of the vertex, 2 points to the left of the vertex, so you get a good solid graph. So if x is 6, well, 6 minus 7 is negative 1. The absolute value of negative 1 is 1. Take that times 3, you get 3. So at negative 6, you'll also be at 3. At 6 you'll be at 3. And then what about if I put in 5 for x? Well, 5 minus 7 is negative 2. The absolute value of negative 2 is going to be positive 2. take that times 3, you would get 6. So now we can connect the second half of this. And look how steep that looks on either side since you have that coefficient of 3. It indicates that we have a vertical stretch by a factor of 3. And then we have shrunk this horizontally because it's not horizontally elongated. It's shrunk horizontally, but it's stretched vertically. And then we've shifted the graph of the absolute value function to the right 7 units. That's what that x minus 7 means. So that's for that one. Let's do another function here. All right. We have f of x equals the absolute value of x plus 5. First things first, let's find the coordinates of the vertex. So what's the vertex? Well, look inside your absolute value first for your x coordinate of the vertex, all right? You have no h factor. It's literally just the absolute value of x by itself, so your x coordinate of the vertex is at 0. But you do have a k number of positive 5, so that means your vertex would be at the point 0, 5. So we found the vertex to be at 0, 5. Let's go ahead and graph that. Here's your vertex at 0, 5. All right, now let's plot a couple points to the right and to the left of the vertex. So if I put in 1 for the 8 for x, I get the absolute value of 1, which is 1, plus 5 is 6. So I would be at the point 1, 6. Then if I put in 2, I would get 7. So let's go ahead and graph that side of the absolute value graph. Let's say I put in negative 1. The absolute value of negative 1 is positive 1, plus 5 would end up giving you 6. Let's say I put in negative 2. The absolute value of negative 2 is positive 2, plus 5 would give you 7. So there is the graph of this function. Literally all this has done is taken the graph of the original absolute value function and shifted it upward 5 units. I just shifted it up 5 units. That's all I did. There's no stretch or shrink. There's no right or left shift. I just shifted the original absolute value of x function upwards 5 units. That's all I've managed to do. But finding your vertex is instrumental so you know where the v is. All right. All right, so we have f of x equals negative of the absolute value of x minus 8, all that plus 1. First, find your vertex. Ignore that negative 1 on the absolute value, all right? Just look at the x minus 8. Let's find the x coordinate of the vertex. So find that x coordinate. The x coordinate of the vertex, of course, set x minus 8 equal to 0, you would get the x coordinate being 8. So your h is 8. That's your h value would be 8. So that's your x coordinate for the vertex. You have a k value of 1. So your vertex would be at 8, 1. So we found the vertex to be at the point 8, 1. 4, 5, 6, 7, 8. Which would be right there at the point 8, 1. Now, you have a negative sign on the front of the absolute value, which indicates it's also going to reflect the original absolute value of x graph. So it's actually going to be a v going downwards. So let's put in 1 point to the right of the vertex. Let's say I put in 9. If I put in 9 for x, 9 minus 8, that's 1. The absolute value of 1 is 1. Negative of that's negative 1. So negative 1 plus 1 is 0. I'll end up getting the point 9, 0. Now if I put in 10 for x, 10 minus 8 is 2. The absolute value of 2 is 2. Negate that, you'll get negative 2 plus 1. That would give you negative 1 for your y value. So you'll have the point 10, negative 1. Go ahead and graph this side of the absolute value function. Alright, let's go ahead and put in 7 for x. 7 minus 8 is negative 1. The absolute value of negative 1 is going to be positive 1. If you negate positive 1, you get negative 1. So negative 1 plus 1 is 0. So you would get the point 70. Now what if I put in 6? So 6 minus 8 is negative 2. The absolute value of negative 2 is positive 2. If you negate that, you'll get negative 2 plus 1 will give you negative 1. So at 5, you're at the x coordinate, at the y coordinate negative 1. So now connect this side of it here. And there you go. There is your graph of this function. So we have taken the original absolute value of x function, we have reflected it in the x-axis since there's a negative sign on the front. We have shifted the vertex to the right 8 units and up 1 unit. So that's what it does. It shifts the whole graph to the right 8 units and up 1 unit, and it's reflected in the x-axis. And if you're wondering what your line of symmetry is, just set x minus 8 equal to 0. The line of symmetry is at x equals 8. It would run right through your vertex. So, pretty cool. Go down. There we go. Put one here, put one here. There we go. All right, f of x equals 1/3 of the absolute value of x minus 3 plus 4. Okay, so f of x equals 1/3 of the absolute value of x minus 3 plus 4. Well, ignore that 1/3 for a minute. Just find your vertex. So to find the x-coordinate of the vertex, take your x minus 3, set that equal to 0. You would get an x-coordinate of 3. Then you have this plus 4, your k value of 4. So your vertex would be at the point 3, 4. So the vertex will be at 3, 4. So let's find 3, 4. That's going to be right there. There's your vertex. And since it's a positive 1/3 coefficient, your graph's going to open upward. It's going to go upward. If it were negative, it would go downward. So the positive or negative indicates which way the graph's going to go. All right. Well, now let's put in a couple values here for and graph them. What if I put in x equals 6? 6 minus 3 is 3. The absolute value of 3 is 3. What's 1/3 of 3? That's 1, plus 4 is 5. So I'd have to go all the way to 6 till I get a coordinate of 5. So I get a y value of 5. Let's say I put in 9 for x. Well, 9 minus 3 is 6. What's the absolute value of 6? Well, that's 6 times a third, that's 2, plus 4 is 6. So I'd have the coordinate 9, 6. Let's graph this side of the absolute value function. All right. Now, let's say I put in 0 for x. 0, of course, 0 minus 3 is negative 3. The absolute value of negative 3 is positive 3. A third of that's positive 1 plus 4 is 5. All right, let's say I put in negative 3 for x. Negative 3 minus 3 is negative 6. The absolute value of negative 6 is positive 6. Times a third is 2, plus 4 is 6. And there's my absolute value graph. So notice it's shrunk vertically. It's not as vertically steep, but it's elongated more horizontally because of that 1/3 coefficient. So we have taken the original absolute value of x graph, we've horizontally stretched it by a factor of 3, we vertically shrunk it by a factor of 3 since the coefficient's 1/3. And we shifted the whole graph to the right 3 units and up 4 units. That's the transformation of this absolute value function. Should only have a few more left here. Alright, so we have f of x equals negative 2 times the absolute value of x plus 9, all that plus 3. First thing again, find your vertex. So ignore that coefficient for a minute. Take that x plus 9, set it equal to 0, you would get x equals negative 9. So the x coordinate of the vertex is at negative 9. The y coordinate of the vertex, just take your k value of 3, so the vertex will be at negative 9, 3. So let's plot negative 9, 3. So there's my vertex at negative 9, 3. Okay. Now, let's put in a couple points to the left and to the right. Let's say I put in negative 8. If x is negative 8, what do I have? Well, negative 8 plus 9 is positive 1. The absolute value of positive 1 is 1. Times negative 2 is going to be negative 2 plus 3 would be positive 1. So negative 8, I would have the y coordinate of 1. Let's put in negative 7. So negative 7 plus 9, of course, is positive 2. The absolute value of positive 2 is 2. Times negative 2 is negative 4. Plus 3 is negative 1. So there's negative 7, negative 1. So let's go ahead and graph this side of the absolute value equation. All right, let's put in negative 10 for x. Negative 10 plus 9 is negative 1. The absolute value of negative 1 is positive 1. Times negative 2 is negative 2. Plus 3 is positive 1. Then if I put in negative 11, negative 11 plus 9 is negative 2. The absolute value of negative 2 is positive 2. Times that factor of negative 2, which would give you negative 4, plus 3, which would give you negative 1. So now we can graph this function. All right. There's the graph of this function. So what happened between here and the original absolute value of x? Well, we've definitely reflected it across the x-axis because you got the negative sign. It's a reflection. You have also vertically stretched this by a factor of 2, which means you've horizontally shrunk it by a factor of 2. You've also taken the graph, you shifted it 9 units left and then 3 units upwards. So that's the transformation between the original absolute value of x and what you see here. And I think we'll do... let's do 2 more. Alright, so f of x equals the absolute value of x minus 5. So this should be easy. We need to find the vertex first. We have f of x equals the absolute value of x minus 5. Well, let's find the vertex. Notice something. You have no h value inside the absolute value function there, inside the absolute value brackets. You just have x by itself, meaning the x coordinate's at 0, but you have a k value of negative 5, so your vertex will be at the point 0, negative 5. So let's plot our vertex. There's 0, negative 5. Now, let's plot a couple points. Let's go to the right. Let's say I put in, for good measure, why don't we put in 5? If x is 5, you get 0 minus 5 is 0. So we'll have the point 5, 0. Let's put in negative 5. X is negative 5, you would still get the absolute value of that being 5 minus 5 is 0. Let's just connect those points. And then what do you know? There is your absolute value of x function in this case, absolute value of x minus 5. So we have taken the original absolute value of x function and just shifted it downward 5 units. That's all we've done. There's no reflections, no stretches, nothing like that. That's all we've done here. All right, one more, then we're done. Alright, so we have f of x equals negative 1/2 times the absolute value of x plus 6. First find your vertex, which means you ignore the coefficient for a second. To find your vertex, take what's inside of the absolute value, set it equal to 0. So x plus 6 equals 0 would give you the vertex being at the x-coordinate of negative 6. You have no k value here, so your y-coordinate of the vertex is at 0. So you got the vertex negative 6, 0. Let's go ahead and plot that. There's my vertex at negative 6, 0. Now, this negative sign on the front of it tells me it's going to be reflected across the x-axis, so it's going to open downward. So, what if I put in negative 4, alright? Let's say I put in negative 4 for my x value here. Negative 4 plus 6 is positive 2. The absolute value of 2 is 2, times negative 1/2 will give you negative 1. Let's say I put in 0 for x. 0 plus 6, the absolute value of 6 is 6, times negative 1/2 will give you negative 3. So now I can go ahead and start graphing this way. Alright, let's put in negative 8 for x. If x is negative 8 plus 6 is negative 2, the absolute value of negative 2 is positive 2, times negative 1/2 will give you negative 1. What if I put in negative 12? So negative 12 plus 6 is negative 6. The absolute value of negative 6 is positive 6. Times negative 1/2 will give me negative 3. And there's my graph of this function. So what's changed between this function and the absolute value of x by itself? Well, the negative sign indicates a reflection in the x-axis. That coefficient of 1/2 indicates that I've vertically shrunk it, so it's not as vertically tall, but it's more horizontally elongated. And then I've shifted everything to the left 6 units and up or down 0. I've only shifted it to the left 6 units also. So that's what all this indicates from the original absolute value of x. So that's it for this lesson. Next lesson, we're going to start our systems of equations unit. Very next lesson, we'll talk about, it'll be a short lesson on solving systems of equations by graphing them or inputting solution points. So I hope everyone has a great day. Take care.